Imagine you're putting together a tower of blocks. You can have 1 block, 2 blocks, 3 blocks, or even 0 blocks. But can you have negative 3 blocks? No, you can owe someone 3 blocks, but you can't physically have negative 3 blocks sitting on a table. That simple idea leads us to a very important group of numbers, whole numbers. Whole numbers are the numbers we use to count complete things. They begin at 0 and keep going forever. 0, 1, 2, 3, 4, 5, and so on. So here's the official idea. Whole numbers are 0 and all the positive counting numbers. Let's write a few examples. 0 is a whole number, 1 is a whole number, 12 is a whole number, 100 is a whole number, and 5,208 is also a whole number. It doesn't matter how large the number gets. If it represents a complete amount with no part missing, it can be a whole number. A number line is a great way to see this. At the center we have 0. Then moving to the right we have 1, 2, 3, 4, 5, and the numbers continue forever. Every point starting at 0 and moving right is a whole number. That means 0 is not an exception that we forget about. 0 belongs in the whole number family. Think of it this way. If there are 0 apples in a basket, there is still a complete count. The basket has none. Now let's look at numbers that are not whole numbers. First, negative numbers. Negative 2 is not a whole number. Why? Because whole numbers start at 0. Negative numbers are to the left of 0 on a number line, so they're not part of the whole number set. Next, fractions. 1/2 is not a whole number. That is because 1/2 is only part of an object. Whole numbers count complete objects, not pieces. 3/4 is not a whole number either. And decimals, like 2.5, are also not whole numbers because 2.5 means 2 whole objects and part of another one. Here's a helpful question you can ask yourself. Does this number represent a complete amount starting from 0? If yes, it may be a whole number. If it's a negative, has a fraction, or has a decimal part, then it's not a whole number. Let's try some together. Is 7 a whole number? Yes, 7 is a complete counting number. Is 0 a whole number? Yes, remember 0 is where whole numbers begin. Is negative 9 a whole number? No, it's less than 0. Is 1/3 a whole number? No, it's only part of one whole. Is 42.6 a whole number? No, it has a decimal part. Now, whole numbers are not only useful for counting objects, they are also useful for comparing amounts. Suppose one student has 4,582 points. Another student has 4,582 points. Which number is greater? No, they're equal. Both numbers have 4,000, both numbers have 500. Now compare the tens. Oh, 8 tenths is greater than 2 tenths. So 4,582 is greater than 4,528. We can write that using the greater than symbol. 4,582 is greater than 4,528. Whole numbers are like addresses along a road that starts at 0. The farther right you move, the greater the number becomes. So on a number line, 9 is greater than 6 because 9 is farther to the right. And 6 is greater than 0 because 6 is farther to the right than 0. Your turn. Look at these 4 numbers. Negative 4, 0, 8, and 3.2, which are whole numbers. The whole numbers are 0 and 8. Negative 4 is not a whole number because it's below 0, and 3.2 is not a whole number because it includes a part of a number. Let's recap. Whole numbers are 0 and the positive counting numbers. They are complete amounts. Examples include 0, 3, 25, and 1,000. Negative numbers are not whole numbers. Fractions are not whole numbers. Decimals are not whole numbers. And on a number line, whole numbers begin at 0 and move to the right forever. Once you can recognize whole numbers, you're ready to use them for counting, comparing, ordering, and solving bigger math problems. Let's keep going and follow for more.